Here in question number 10.11, how will you bring about the following conversions? So here two conversions we are doing in part 1. First one is ethanol to but-1-YN. So it is ethanol is CH3 CH2 OH and this is ethanol, which should be converted to YN and more carbon atoms also. So first of all, we have to convert this to halide. And for halide, when OH is replaced by halogen, there are so many methods. Out of that, we are selecting SOCl2 reaction, which is in presence of pyridine. This reaction is selected because here the byproducts which are formed, that is SO2 and one more HCl, all are gas. So they are removed from the reaction mixture and you can get the pure halide compound which is required for the next reaction. So it is CH2Cl. After that, this is your chloroethane. So you can give the name also chloroethane. Then this should be converted to next one, that is the final product, and for that it should be treated with some sodium salt, and this sodium salt is actually C minus triple bond CH. This is sodium acetylide, and by this reaction sodium chloride is formed and you can get the final product, that is CH3 CH2 CH, and this compound is the but-1-YN. Now in the next compound, next conversion, here during conversion always remember that whatever byproducts is formed, that should be below the arrow, and whatever reactant is used, that we are using always above arrow, and the product which is formed, the main product, that should be written in the same line, and that product is also after that how the intermediate is converted to next product, that all should be in one line and all the byproducts should be side. So ethane here, ethane, that means CH3, CH3. This compound is used and it is treated with, so it should be converted to bromoethene. So first of all, it should be treated with bromine. That means bromination we are doing, but this bromination should be in presence of UV light it should be, or it can be heated also, in presence of heat also this reaction is possible, and one of the products will be the hydrogen is replaced by Br product, and that should be the required compound which is needed for the next step. So CH2Br we can write here, and after that in the next step again we have to use some reactant to convert this to alkene, and alkene, and for this alcoholic KOH should be used. So KOH is alcoholic, and by this again HBr is removed, and dehydrohalogenation this is, and by this the product which is formed is ethene. So ethene is the product formed, CH2 double bond CH2. So this is ethene, and this is bromoethane. And this is ethane. So in organic chemistry, always remember that whatever structure you are writing, give the name below it, and it is must. By that only you can get full marks in any question. So after this, again it should be subjected to bromination, but this bromination is addition of bromine. So here the addition of bromine should take place, and for that the reagent we have to use is just bromine in carbon tetrachloride, and by this two more hydrogen are replaced by bromine, and the product formed will be, it is actually addition of bromine at the double bond. So we can write CH2Br and CH2Br. So 1,2-dibromoethane is the product formed. CH2 at the double bond, bromine addition is taking place. So it should be this compound. And this is your, we can say 1,2-dibromoethane is the product formed. And after that, actual product we need is different. So we have to do the removal of HBr, that is dehydrohalogenation again. And for this dehydrohalogenation, again we are using the same reagent, that is alcoholic KOH. So this is alcoholic KOH, and by this one HBr is removed. HBr is removed, and the product will be final product, and that product is bromoethene. So it is CH2 double bond CHBr. Bromoethene is the final product.